going to be talking about equations of parallel and perpendicular lines. Show me two lines with your arms that are parallel. Very good, yeah. Touchdown, man. Okay, show me two lines with your hands that are perpendicular. Yes, cross at a right angle. Tell your neighbor what you know about the slopes of your parallel lines. Go ahead and put your parallel lines. And go ahead and put them slanted. What do you know about those two slopes? Okay, and tell your neighbor what you know about the slopes of your perpendicular line. Well, that's what you're going to be exploring in this exploration, number 1 here. Okay, spend some time, page 86 of your student journal. Work with your partner there. All right. Let's go ahead and get those equations up here. Let's go row 1, you guys get letter A. Row 2, you guys get letter B. Row 3, this group right here, you guys get letter C. You guys over there get letter D. You guys get letter E. You guys get letter F. All right? You guys don't get anything. Okay, go ahead and write your equation up. Agree on it as your group there.
Wow. No, don't write it in different colors. Oh. Can we write in pens? Oh, that's too bad. Not mine. Too bad. She's gonna write in pen. Write in pen. Here, give me your pencil. Shelby, you just give everybody. I know. Nice. Did you just throw something? No, that's awful. That looks ugly. Oh my goodness. Like your face. Oh. What? Yeah. Or you can use my pencil over there. He says he doesn't want any pen. Oh, nice. That's me. If he would let us do it in pen, he would. He won't let us color the world. Color the world, Shelby? Yeah, we're coloring the world. Right? Hey, Maddie, apparently we're coloring the world. Yeah. What? We're coloring the world. He's not allowing us to color the world. Yeah. Doesn't look good. We need to fix that. Oh, I just threw it on the table. Oh, well. Where? Oh, well. Shelby, do you want your pencil? Oh my gosh, you're so lazy.
All right. Well, here we go. Looks like we got them all up there. Oh, except for letter D. Who missed D? Oh, I thought you were. Oh, no, I thought you were. All right. One of you will. Come on up.
Shelby almost ran in coffee.
Yeah, because I was trying to drink the rest of it, and there was more than I thought.
Captain America coffee.
Yeah, I love
I'm
it.
Captain America for Halloween. I love this big shield with all the
Here you
skins
go.
I am. Because I'm so small. Like, the shield is like
Because
this
you're wearing
big,
a
it's like tall.
I did a picture.
12th man
Red
jersey.
last year.
Okay,
It was
that's
very
not
crazy.
Not the Brady.
That's okay.
Not the Brady punk jersey. Not that I don't like Brady. I don't like Brady.
Alright, I'll pay them 50.
Coffees are 12th man number.
Because it's like, I wish.
Hold on. Okay, here we go.
So cool.
All right, you guys had to send Hunter up here with that jersey. I don't know about your group, Jordan. Send Hunter up with a 12th man jersey or a Tom Brady jersey. All right, I think Tom Brady and Aaron Rodgers both copied the 12th man, but they yearn to be in Seattle. No worries. Yeah, he's kind of unlucky right now. All right.
So Andrew Unlock.
Andrew Unluck. All right, pretty good quarterback still. Okay, so on this guy right here, letter A, we're writing an equation of a line that is parallel or perpendicular to the given line, and passes through the given point. So here's the given point. Here's the line. It has to be parallel to this. So if I'm saying a line that's parallel to 3/2 x minus 1, and I write 3/2 x minus 1, what kind of problem we have there? Yeah, that's the exact same line, dude. Okay? So really we have the right slope because the lines that are parallel have the same slope. We determined that, or most of you agreed to that when we started this. However, our y-intercept is actually 2. And is it minus 2? It's plus 2. Okay, so if you call y equals mx plus b from algebra days, m is your slope, b is your y-intercept. All right? That's all right. That's why we do these. Okay? At least some people come up here. Yeah. All right? Any questions there? Letter B. Well, actually, let's go to C. Okay, so slope is 1/2. Why? Because they're parallel and they have the same slope. Very good. And y-intercept is at -3. Yep, very good. Good to go right there. Let's go on to letter E since we're sticking with the parallel theme. Slope -2, -2. Good. Crosses at -2. Awesome. Okay. So we got parallel, right? Carlo? How you doing? No, the other Carlo in class. I'm just checking. I want to make sure you're okay. All right. I worry about you. All right. Our slope of this line is 3/2. The slope of one that is perpendicular, -2/3. Everyone agree that's true? I mean, you cross at 1. That's for sure true. And so what you're saying is you go down 3 or down 2, and you run 3. Right. Okay, so you go down 2, 1, 2, and you run 3. 1, 2, and 3. Good. All right, looks like we're good there. Let's move on here. 2x plus 1. You're at 1. And so you're saying if you go down or up 2 and then over 1, you'll be at another point on that line. So 1, 2, over 1. Everyone agree? I think it should be negative. Yeah, we have to go. This line is falling from left to right. So remember, if a line's falling from left to right, might be a thing to review. That's a negative slope. Versus rising from left to right, we call that positive slope. Okay? Munti. Oh, hold on. Don't give away the end of the movie yet, man. All right. Let's make sure your theory holds true right here, Munti. Okay? At -2, and then you rise 1, and you run 2. Did it work there? Okay. So go ahead, Munti. Tell us on perpendicular what happens. Good, yeah, and it's probably easiest to see with letter B, but you take the slope and you take the reciprocal, which means you flip it, turn it upside down, and you make it opposite of what it was. If it was positive, it becomes negative. If it's negative, it becomes positive. Okay, so for instance, in this one, 1/2, when you flip it, becomes 2. It was positive, now it's negative. Here, -2, when you flip it, becomes 1 over -2, and then you change the sign to positive. Good. All right, so right now you need to summarize parallel lines, perpendicular lines. What do we know about parallel lines and their slopes? What do we know about perpendicular lines and their slope? Go ahead and write that down. All right, a good place for you to maybe summarize some of this stuff on the page 87. You can write an equation of a line that is parallel and perpendicular to a given line and passes through a given point. How can we do that? Okay, talk about what your slopes have to be. Parallel lines, what are the slopes? Perpendicular lines, what are the slopes? What happens there? Okay, parallel lines, slopes must be the same with a different y-intercept. Perpendicular lines, slopes are inverse reciprocals. And if that doesn't make a lot of sense, make sure you give yourself an example, like what the inverse reciprocal is. All right, so if you have 3/4, the inverse reciprocal is negative 4/3. Okay? The other way to think about it is the product of these slopes of perpendicular lines. What's the product when you multiply? All right. Everyone multiply 3/4 by negative 4/3. If you're doing it on a calculator, that is absolutely and utterly ridiculous for advanced students. For any student. For non-advanced students, you should be able to do that by hand. For those of you like, I don't know how to multiply fractions, there might be an app for that. You may have to get it. Okay? I don't know. Multiplying fractions? Hey, cross cancel. Or, even if you don't cross cancel, you multiply straight across, you get negative 12 over 12, which is negative 1. The product of the slopes of perpendicular lines is negative 1, always. Easier if you cross cancel these. Which gives you negative 1 as well. If you don't know how to work with fractions really well, between now and advanced algebra, Algebra 2, the class you'll take next year, you really need to put in some effort there. So studying up, going online, making sure you're at the Math Academy this summer, you know, whatever you have to do to get used to fractions, because you use a lot of fractions next year. And they're not like these fractions. You put quadratics in the fractions, like x squared plus 4x minus 2 over 3x squared minus 2x plus 4. You do all kinds of cool stuff with it. Pretty cool. All right. So, let's see if we can truly do this. Number 4, write an equation of a line that is parallel and perpendicular to that line right there, y equals 3x plus 2, and passes through that point. Work together with you. To clarify, you're writing two different equations. I mean, you can't have one equation that's going to be both parallel and perpendicular. So, two different equations. Hey, it was interesting. Some of you finished this really fast. Some of you are still sitting there, yeah, you're not quite sure what to do. How many have heard of point-slope form? How many have heard of slope-intercept form? Y equals mx plus b. How many know how to raise their hand? Some of you are struggling with the hand-raising thing. Okay? If you can't figure out how to raise your hand, that's tough. Okay? Point-slope form. Y minus y1 equals x minus x1. I agree, but you're missing a piece. Point, those are your points. Point slope form. What are we missing? The slope. M stands for your slope. X1, Y1 stands for a point. M is slope. X1, Y1 is a coordinate. Okay? How many remember doing that in algebra? Okay, I know if you had me for algebra, we did it for like not too long. Okay, we didn't use point slope for too long. But I think if you're given a point and you know the slope, it's very easy to use point slope form. Okay, good thing you're wearing safety glasses there, Abdul. Yeah. All right. So, if I am given if I want a line that's parallel, let's start with part A here. A line that's parallel to this line. Tell your neighbor what the slope is. Okay, time's up. What do you think, Danica? It is 3. Very good. Okay, and Isaac, what point does it need to go through? No. Good, 1 to negative 2. All right, so you have a point, you have a slope. If we use point-slope form, I want everyone to plug this into this equation, please. On your paper, you get 15 seconds to do so. Time's up. Y minus, here is x1, here is y1. So y minus negative 2 equals m, which is that, 3 times x1, or x minus x1. X minus 1. All right, notice I use a bunch of parentheses. Every time I put something in, I put it inside parentheses. So when you do that sometimes, especially if you're not very familiar with the language of math, sometimes you're like, where did all those dopey parentheses come from? Well, that's all those things that you just plugged in. Okay, the more you do math, the more you get used to seeing the parentheses and go, oh, I put something in there. Okay, so I have y plus 2, right? Two negatives make a positive. Equals 3 times x minus 1. So now I get rid of the parentheses because I've done the substitution. Okay, distribute. What do we get? 3x minus 3 equals y plus 2. And y equals, what are we going to do? Go subtract 2 from both sides, 3x minus 5. That is my equation. How many got that equation right? How many did it a different way? Yes, you can do it a different way. How many of you think your way is quicker? Okay, we can race later. All right. Let's use point-slope form to find one that's perpendicular. So tell your neighbor what the slope is of a line that's perpendicular to our equation. All righty. Patrick, what do you think? Negative 1/3. I agree. Okay. And what points does it need to go through, Sam? What's that? And? Need the coordinate 1, -2. Okay. So everyone use point-slope form. Write your equation. You get 10 seconds this time. Time is up. Gino, we get y minus what? So there's x1, there's y1. What goes here? Nope. -2. Good. Equals, Sophia, what goes here? Negative 1/3. Okay, Maddie Anderson, what goes here? No. Well, it will be 1. Oh, x and then 1. Yes. All right. Very good. And when we write it without the parentheses, it is y, what, Drew? Minus -2, which is? +2. And Nathan, what do we get here? Negative 1/3 x plus Carlo? Not plus 5/3. Yeah, quit staring at Jordan. Pay attention to this. Go ahead, Brennan. Plus 1/3. Yes. All right. So from there, we now, what do? Subtract 2 from both sides. Y equals negative 1/3 x. And we subtract 2. 1/3 minus 2 is? Some of you are like, huh? Dude, that's like negative 5/3. That almost sounds like what Carlos said. Oh, you weren't right. You didn't answer the question.
Close enough.
What do you mean close enough? I'm not playing like horseshoes or something. Okay? Hey, 2, just so you know, how many thirds is 2? 2 times 3 is what? 6. So when I say I subtract 2, I'm actually subtracting 6/3 from 1/3, which is negative 5/3. Once again, you guys get it. You have to become proficient with fractions. Anyway, there you go. Cool, man. How many got it? All right. Any questions? Yes, Danica. Can you just like write it down without showing any work? Yeah. No. You should show work. Okay? Yeah, you got to show work, guys. I mean, those of you that don't show work, in fact, there are a couple in here that are very smart. You do things in your head, but then you go to get partial credit. And I can't give any partial credit. And what ends up happening to the students that don't show work And usually those students don't listen to me because I was one of those students, so I know I've heard this conversation that I didn't listen to from my teachers. It didn't catch me. Well, you can hear and not listen, right? I mean, I'm sure, Isaac, you've heard your parents plenty, and there are times when you don't listen to them. Are you correct? Hey, I mean, you guys, that's a part of life. Sometimes you hear things and you just don't listen to it. You hear advice, you don't listen to it. Okay? So, what I'm saying is, and it's a good question, is like, it caught me, like I was really good at math, it caught me my first quarter of college. That's when it caught up to me. Tough way to learn because A, cost me money, a lot of money. B, cost me a quarter because I dropped out. And it was my math class that caused me to drop out. Because the skill I had in high school of doing things in my head and not kind of showing a lot of work and taking good notes. In college, when you do chapters at a time and you're reading books and you're supposed to take notes and learn the material, it doesn't work so well. So if you learn it now, you learn a good skill now, then when you get to college, you won't be paying the price of headaches and tough goes. But if you're only hearing me right now and you don't listen to me, then at least this is being, I didn't pause it, it's being recorded. You could always come back to this video and you could say, oh dude, he did say so. I heard it. Man, I should have listened. I heard. Should have listened. All right? But it's a good question. I appreciate the question. All right. Just in case you didn't recall, there's slopes of parallel lines and perpendicular. It's there. Some notes on it. I want you to take a look at your student journal, page 89. 89er. Number 1 and 2. Actually, start number 1 together with your group. What do you mean? Sliver of hope. There's no slivers. Oh, that's good. All right. Well, let me define some things first. A directed segment, that would help. A directed line segment is a line segment that's going in a particular direction. So if we're saying a directed segment from A to B, that means, and I have no idea if this probably is not the right segment, but if this is A and this is B, you are going in that direction from A to B, not the other way. It's a directed segment. Okay? All right. So, fine. Well, I guess you can kind of think of it that way. But it's a directed segment. It means you have to travel. It's like a one-way street. All right? Okay? You're going from point A to point B. Find the coordinates of point P. So point P is somewhere along the segment. Right now it has nowhere to stop. It's just running back and forth between A and B. Poor little P. Okay? Oh, no, it can't. I guess it just ran that way and stopped. I guess you can't go back the other way. Otherwise you're breaking the law, right? Because it's a directed segment. Unbelievable. Okay? So, with that being said, find the coordinates of point P along the directed segment AB so that AP to A or to PB is the given ratio. What? I know. Like, what does that mean? Well, that means if you have A to B and you have a segment and then you put point P on here somewhere, the ratio is the ratio that they're giving you. So like this looks like maybe a 2 to 1 ratio, right? There are 3 parts, 2 parts here, 1 part there. It's not quite that, but you know. All right. So this is saying a 3 to 1 ratio. How many parts are there then?
4.
There are 4 parts. 4 parts. And what I know if I go from this point to this point in a certain direction, okay? Let's actually figure out what the slope of that line is real quick. Use your slope formula. How many remember the slope formula? There are 4 seats on the right of the slope formula. It's y2 minus y1 over. Good. So our 4 seats, there, minus there, there, minus there. Those are our 4 seats on the ride. It's a fun ride. Sometimes it's really steep. Sometimes not so much. Come on, man. Whatever. All right, this is x1, y1, x2, y2, or vice versa. In C, y2, you get 1. In C, y1, you get 7. In C, x2, you get -4. In C, x1, you get -2. You get a grand total of -6 over -2. All right, now, usually we'd reduce that to +3, correct? Okay, we're not going to reduce that right now. All right, because we're going to use that with our 4 parts here. Okay? So I'm going to pause just to make sure everyone's clear on what to do from there. So make sure your neighbor's good to go. You good? Hey guys, let's make sure that we're clear. We're clear on what's happening here so that you understand. I don't want you to think this is just some random stuff you're doing. Okay? So if I were to plot these points, -2, 7, -2, 1, 2, 3, 4, 5, 6, 7, that's there. And -4, 1, so that's point A. Thank you. Okay, -4 and 1, that's there. Good? And we're going in this direction. All right? How many of you remember finding slope using a picture? What did you do? Rise over run. So really, to get from here to here, you're rising and running. We're rising -6 and we're running -2. Negative because we're going down, negative because we're going to the left. So since we're going 4 parts, and we want point P to be 3 of those parts away from A, or 1 of those parts away from B, you're saying I want it to be 3/4 of the way down this line, or 3/4. Okay, 3 out of 4 parts. You guys with me on that? So really, I don't want to rise all the way down 6 units. I want to go 3/4 of that. Okay, what is 3/4 of 6, or of -6? Okay, what's -6 times 3? -18. Divided by 4, which is -9 over 2, which is -4.5. So that means we actually rise -4.5 from this point. What does that mean? Well, it means if I'm at -2, I'm going to subtract 4.5, and I get to -6.5. No, hold on. Sorry, we did that to the x value. It needs to be the y value. My bad. Right? Because our rise deals with y. So 7 minus 4.5 is 3.5. We do the same thing here. -2 times 3/4, which is? What is it? Yeah. Oh, 2.5. Thank you. 7 minus 4.5. KJ? With a -2, you'd be multiplying it by 3/4 still because you're moving down 3/4 and over 3/4 of that. Okay, so this would be -1.5. Hey, point P is at -3.5, 2.5. All right.